In the late 1920s, Curtiss was already famous for its flying boats. The company designed a family of Hawk fighters for the U.S. Navy and Marine Corps. Initially, these were conventional biplanes. They were built to operate from land bases or aircraft carrier decks. But the military always wanted more. They wanted to expand what these aircraft could do. This led to the development of a floatplane version. In this new role, the aircraft excelled. It became a textbook example of how to successfully convert a land-based fighter into a highly capable seaplane. This success wasn't an accident. It was built on the most advanced technology of the era. In fact, ever since 1917, Curtiss had been aggressively chasing new aviation technology. Curtiss gained early experience with these new technologies by building modern French and British aircraft under license. The initial plans were incredibly ambitious. They called for the mass production of 2,000 British Bristol F6C seat fighters. They also wanted 1,000 SE-5 fighters and 3,000 French SPAD-13s. But reality had other plans. Instead of thousands of F-2Bs, Curtiss only managed to complete 26 airframes. The reason came down to politics and engineering. The U.S. government insisted on swapping out the 250-horsepower British Rolls-Royce Eagle engines. They replaced them with brand-new American Liberty engines, which produced 400 horsepower. The original designer, the British Bristol Aeroplane Company, strongly opposed the change. Following a series of fatal crashes, the contract with Curtiss was simply torn up. Things went even worse with the French fighters. That contract was cancelled before a single aircraft could be assembled. Ultimately, only the British SE-5 was built in the numbers originally planned. Shortly after, Curtiss also began manufacturing aircraft designed by other American companies. This included Orenco D fighters as well as Martin MB-2 and NBS-1 heavy bombers. In early 1918, the U.S. government decided that the military should fly only American-designed aircraft. They began issuing design and manufacturing contracts. This set up competitive trials between aircraft builders. The first aircraft Curtiss entered into this kind of contest was the 18T Wasp triplane. This two-seat fighter was equipped with an incredibly powerful power plant for its day. It used the 400-horsepower Curtiss Kirkham K-12 engine. Thanks to that engine, it briefly held the title of the fastest military aircraft in the world. Impressively, even while carrying a full combat load, the fighter could hit nearly 164 miles per hour. The two Wasp prototypes were completed just as World War I was coming to an end. Interestingly, because of its blistering speed, the Navy ended up using the 18T purely as a racing aircraft rather than a combat fighter. Curtiss kept the momentum going. They entered another high-profile government program. At the time, the Army Engineering Division had drafted a concept for a brand new night fighter. This aircraft was designated the PN-1. Curtiss won the contract to build two prototypes. However, the project ultimately turned out to be a dead end. The factory managed to assemble just a single airframe and it never even flew. However, the effort was not a total waste. It was during this exact project that Curtiss engineers pioneered a new method. They perfected the technique of building a welded steel tube fuselage. This was a major advance in aircraft construction. After this, the designers at Curtiss produced some of the most successful racing aircraft of the era. These were the R2C1 series aircraft. They were powered by D12 and D12A engines. These were new, significantly improved versions of the older K-12 power plant. The design of these racers built on the same advanced technology found on the 18T triplane. Specifically, this featured a laminated wood, semi-monocoque fuselage. Thanks to this innovative approach, the R2C set several world speed records between 1921 and 1925. But there is an interesting bureaucratic twist here. In official Navy documents, these airplanes were classified strictly as experimental fighters. This was because in the post-war era, Congress had barred the Navy from spending federal money on developing racing aircraft. This forced the military to use this kind of workaround. The company rolled out its first true production fighter, designated the TS-1 in 1922. The aircraft was largely designed by engineers at the Navy Bureau of Aeronautics. The initial order was fairly modest. It was just 34 fighters, with the first 5 built at the Naval Aircraft Factory in Philadelphia. Unfortunately, the weak power plant, putting out just 200 horsepower, kept the company from incorporating their latest design advancements. Because of this, Curtiss made a counterproposal. They wanted to completely redesign the airplane and turn it into a modern fighter. In 1924, the Navy finally gave the green light. The military signed a contract for 2 updated aircraft, which would become known as the F6C. The next Navy fighter from Curtiss was a navalized version of the Army P-1 Hawk. It entered production under the new designation F6C. Interestingly, the name Hawk was unofficial, as were all the other bird names Curtiss used for its aircraft. The company started the tradition of naming its aircraft back in 1919, and even though the military usually ignored these marketing names, Curtiss actively used them in its advertising campaigns and official documents to build brand recognition. The primary reason the P-1 design entered Navy service was its powerful D-12 engine. This engine featured a highly reliable water cooling system. The Navy Department initially ordered just 9 F6C fighters. Compared to their Army counterparts, the only major difference was a new Navy paint scheme. Structurally, the fuselage frame of the fighter was constructed from welded steel tubing. The control surfaces and tail section, including the ailerons, vertical stabilizer, rudder, and elevators, utilized lightweight aluminum framing. The tapered wings of the aircraft used the Clark Y airfoil, which was highly innovative for the time. This distinctive wing shape is exactly what makes a Curtiss design so easy to spot today. The wings were braced by end struts, creating a classic and highly rigid biplane structure. The entire internal fuel supply was stored in a single fuselage tank. This tank held about 150 gallons. However, to extend range, an extra 50-gallon belly tank could be slung underneath the aircraft. The main armament of the fighter consisted of 2 synchronized 30-caliber Browning machine guns. The official delivery of F6C aircraft to the Navy began in September 1925. The first example was immediately sent to Naval Air Station Anacostia. There, it went through a series of extensive tests specifically for the Marine Corps. The next 2 airplanes were tested as seaplanes. They were mounted on floats and fitted with a brand new metal propeller patented by Curtiss. This propeller would later become the standard for future modifications. The wooden floats were mounted on special metal struts at the exact same attachment points as the standard wheeled landing gear. Interestingly, they didn't even remove the tail skid for the seaplane variant, but the aircraft still handled well on the water and took off with ease. Ultimately, all production F6C were formally assigned to Fighter Squadron VF2, based out of San Diego, California. The last 4 airplanes from the initial order rolled off the assembly line under the updated designation F6C2. This was a specialized variant designed for carrier operations. It featured significantly reinforced landing gear and a modified tail skid to handle hard landings on a flight deck. In 1926, aircraft from VF2 took part in some highly important dive bombing tests. The flight profile went like this. From an altitude of around 2,500 feet, the pilot would push the fighter into a 45-degree dive. Then, after descending to 400 feet, they would release the bomb. These risky tests were a complete success, proving the structural integrity of the airframe. What's more, in the spring of that same year, one of the floatplane variants of this aircraft secured a major victory in the prestigious Marine Corps Cup race. It clocked what was then an impressive speed of 132 miles per hour. Overall, the first-generation F6C fighters served the Navy right up until early 1931. During this time, each aircraft logged an average of 500 flight hours. As these numbers suggest, they had a relatively light operational tempo and were not flown particularly hard. However, you definitely cannot say the same about their successor, the F6C. This aircraft saw a much heavier flight schedule. This third variant came about through a major upgrade to the F6C. Engineers decided to bring it up to the standards of the Army's latest P-1A pursuit plane. The upgraded aircraft had its fuselage lengthened by 3 inches and was fitted with improved D-12C engines. On top of that, firepower was heavily boosted. On many of these aircraft, the right-hand 30-caliber machine gun was swapped out. It was replaced by a much more devastating 50-caliber heavy machine gun. Eventually, this specific weapons configuration became the gold standard for all American naval biplane fighters. These new aircraft also gained the ability to carry a dedicated bomb load under the fuselage. It was mounted between the landing gear struts in the exact same spot where the external fuel tank used to go. The operational history of the production F6C began in October 1926. The first batch of 18 aircraft was delivered to Fighter Squadron VF5 based in Norfolk, Virginia. Shortly after, these airplanes deployed aboard the brand new aircraft carrier USS Lexington. They even took part in the ship's official commissioning ceremony. This particular squadron became famous as the Red Rippers. Interestingly, the unit is still active today, though they obviously fly vastly different aircraft now. However, the F6C carrier service revealed a frustrating issue. The aircraft constantly skidded while taxiing on the flight deck. Because of this, in the summer of 1928, Navy Command decided to convert all the aircraft into floatplanes. The squadron itself was reclassified as a bomber unit. It received the new designation VB-1B. But the strangest part was that the aircraft stayed aboard the carrier. This awkward arrangement lasted for about a year. Ultimately, the Navy mandated that all carrier-based aircraft had to be powered exclusively by air-cooled engines. As a result, all F6C were gradually transferred to the Marine Corps. The last of these fighters was stricken from the Navy list ashore in June 1932. By that time, it had logged 1,037 flight hours. Deliveries specifically for the Marine Corps began as early as 1927. First, the VF-8M squadron was re-equipped with the new fighters. A bit later, the VF-9M unit followed suit. Both of these squadrons were stationed at Marine Corps Base Quantico in Virginia. However, these aircraft became a real headache for the maintenance crews. The tail skids wore out so quickly that mechanics found it much easier to just put the aircraft on floats. They ditched the wheeled landing gear altogether. It is also worth noting that between 1926 and 1930, some of these fighters were used in a pretty unusual role. They were used as actual racing aircraft. For example, in November 1926, one of these aircraft entered the prestigious Schneider Trophy race as a reserve aircraft. Since the United States had won the event the year before, the 1926 competition was hosted on home turf, specifically in Norfolk. To squeeze maximum speed out of the fighter, engineers did some serious work on the engine. They boosted it to 507 horsepower. On top of that, the fuselage fuel tank was significantly enlarged. This was necessary so the fighter could cover the 214-mile race distance while running at maximum RPM. In the end, this aircraft took a respectable fourth place. It reached a speed of 138 miles per hour. Less famous, but just as interesting, were the races for the Curtiss Marine Trophy. This event was established back in 1913 by aviation pioneer Glenn Curtiss. It was held annually exclusively for Navy and Marine Corps aircraft. The F6C fighters regularly competed in it starting in 1926. They even took home the trophy twice, in 1928 and 1930. Their speeds back then reached nearly 159 and 166 miles per hour, respectively. The 1930 win is especially revealing. First place went to an aircraft that had been designed almost 6 years earlier. This fact really showed just how far American naval aviation technology had fallen behind at the time. When the Navy finally abandoned water-cooled engines, Curtiss didn't give up. They adapted by developing a new variant, the F6C. The Navy was highly satisfied with how the F6C series outperformed competing designs. Because of this, they actually proposed the upgrade idea themselves. They sent one of the early F6C-1 airframes back to the factory. This allowed engineers to install the brand new R1340 Wasp, air-cooled radial engine from Pratt & Whitney. This 9-cylinder power plant pumped out 420 horsepower. Flight tests for the upgraded F6C-1 began in August 1926. As soon as they were successfully concluded, the Navy immediately ordered a production batch of 31 aircraft. The first example of the new series rolled out in the spring of 1927. Fleet deliveries started that summer. Thanks to the new engine, designers managed to shave a full 174 pounds off the aircraft's empty weight. The upgraded fighter boasted an impressive service ceiling of 22,838 feet. Its top speed reached 156 miles per hour. Interestingly enough, right alongside Curtiss, Boeing was also actively testing this exact same new power plant. They mounted it on their F-2B-1 fighter. The first prototype took to the skies in November 1926. The results were so promising that the Navy ordered 32 of these aircraft from Boeing. The first production F6C fighters initially entered service with United States Marine Corps Aviation. By 1930, these aircraft were operating from the deck of the aircraft carrier USS Langley. They served alongside 8 F-2B-1s. However, the Curtiss aircraft were soon refitted. They swapped their standard wheeled landing gear for floats. Later that same year, they were sent back to Marine Corps squadrons. In this configuration, they kept flying right up until 1932. An interesting technical development occurred in 1930. The engine cylinders on some F6C fighters were fitted with town-end rings. They were cheap to manufacture and incredibly easy to install. Engineers hoped this setup would significantly boost airspeed during the upcoming seaplane races. But the expected performance gains never materialized. This completely baffled the leading experts at NACA. It was later discovered that this was caused by detrimental aerodynamic interference. Specifically, turbulent airflow was coming off the ring and hitting the pilot's windshield. Eventually, in 1933, these aircraft were permanently retired from the fleet. They had simply exhausted their service life. The highest time airframe logged a maximum of 1,149 flight hours. Interestingly, in the late 20s, several of these aircraft were actually used as flying testbeds. This took place at Naval Air Station Anacostia. They were testing promising new Hornet and twin Wasp engines from Pratt & Whitney. As for the experimental F6C fighter, outwardly it looked very similar to its Dash 4 predecessor. The main difference was hiding under the cowling. It packed a much more powerful R1690 Hornet engine, also from Pratt & Whitney. However, the engineering team was deeply disappointed. The engine output increased by 115 horsepower. But the aircraft's overall performance improved so marginally that mass production was completely out of the question. The project went nowhere. The F6C family featured one more interesting variant in its lineup. This was the F6C6 monoplane. Essentially, it was a standard biplane with its lower wing removed. However, the airframe itself was custom built for the job. This was how they prepped the aircraft for the prestigious 1930 National Air Races. To squeeze out maximum performance, engineers streamlined the landing gear as much as possible. They also dropped in a powerful inline Conqueror engine. They were lucky that strict Navy Department restrictions did not apply to racing aircraft. Unfortunately, the story of this aircraft ended in tragedy. It crashed and the pilot was killed. This disaster permanently ended the Navy's participation in the National Air Races. So how was this aircraft put together? The F6C Hawk was a classic single-seat, single-engine biplane floatplane fighter. Its fuselage featured a truss structure and was built as a single, rigid unit. Simply put, the aircraft's skeleton consisted of steel tubing. This tubing formed its longerons and crossmembers. Engineers needed to ensure the entire airframe held together and would not twist during hard maneuvers. Therefore, the structure was internally cross-braced with heavy-duty steel cables. The engine mount was attached to the front of the fuselage frame. Around the engine compartment, the airplane was skinned with panels of light but tough duralumin. The rest of the airframe was covered in standard aviation fabric. Mechanics needed easy access to the internal components and control linkages. To provide this, laced access panels were sewn directly into the fabric covering. The forward duralumin panels, on the other hand, were fastened with screws. Here's a neat detail. To keep those screws from vibrating loose in flight, they were safety wired. The cockpit was completely open. The only wind protection came from a clear windshield made of a single sheet of plexiglass. Interestingly enough, the floatplane versions of this aircraft didn't even get an optical gun sight. The pilot seat itself was made of duralumin. They added a padded headrest for a bit of comfort. The instrument panel was as bare bones as it gets, holding only the absolute essentials. The altimeter was on the right. The tachometer for monitoring engine RPM was on the left. The airspeed indicator sat right in the center. The wings had a trapezoidal shape. Their internal structure was built around a two-spar wooden frame and a series of ribs that formed the airfoil. The upper and lower wings were completely identical in construction. However, the ailerons were only installed on the upper wing. These control surfaces were used to roll the airplane. The linkage operating them was actually pretty clever. The pilot pulled control cables routed through the lower wing. That input was transferred up to the ailerons using long metal push rods. To keep the two wings firmly locked together and handle the heavy flight loads, they were reinforced with steel struts and bracing wires. The wings were fabric covered. Just a few metal fairings were added at the lower wing's roots for extra structural strength. Structurally, the tail section was built a lot like the wings. Its framework was also made entirely of wood, except for the control surfaces. It was similarly covered in fabric. The elevator and rudder were actuated by a reliable cable system routed all the way back from the cockpit. Instead of standard wheeled landing gear, this aircraft sat on the water on a pair of massive floats. These were built completely out of wood. To make them more durable and watertight, the plywood skin was carefully wrapped in fabric heavily soaked in varnish. Heavy-duty steel struts attached these floats to the fuselage. Interestingly, the designers wanted to keep the system as simple as possible, so they didn't even include water rudders for taxiing. Looking at the internal layout, the engineers placed the main fuel tank right in front of the cockpit, just behind the firewall. The 10-gallon oil tank was mounted slightly above it. The cooling system was packaged really nicely. They tucked the oil cooler right underneath the engine, directly next to the water radiator. To manage engine temps, the pilot could manually control the cooling airflow. They used a dedicated cockpit lever to open or close the horizontal radiator louvers. And of course, we can't forget the armament. The airplane's firepower came from 2 synchronized machine guns. Ammo capacity was pretty solid, allowing for sustained engagements. Each gun had its own ammo box holding 600 rounds. On top of that, the aircraft could handle light bombing missions. A centerline rack under the fuselage was normally used for an external fuel tank. It could also carry a few small bombs if needed.